Wow, I could really make your lives miserable. Okay, let me get your attention. Second to last lecture of the semester. I don't know about you, but I'm getting excited. Announcement. So you've all by now experienced online course evaluations, yes? And you think this is a fabulous thing. And it's not. It's actually really controversial. And there are a lot of us, myself included, who think that this is actually not such a great thing. It's why are we doing so? The deal is that we now have, the way we do course evaluations is instead of having a bunch of paper and you write things down and circle things and we collate it and put it into a computer, we now have an online little thing. You go to a certain site and you select Econ 119 and you authenticate, and you enter the stuff. Now, can anybody guess what happens to overall response rates when you switch from a paper system like we've always done to an online system when you can just go and do it anytime you want? Response rates skyrocket. Yes. No. What happens is that people basically, it's like, oh, people can do it anytime. That should make it happen, right? We've expanded your choice set, so you should do it more. We know that's wrong. We know that what works best in a lot of cases is to give you a narrow window and then basically step on your neck until you do it. So this actually has pretty serious implications for teachers. You're all familiar with Yelp. Okay? How often do you go on Yelp and see reviews that say, this restaurant was fairly good, nothing really bad about it, nothing extremely exceptional? Right? How often do you see reviews that say, pretty good restaurant, on average I'd say I'd go again? You don't. What you see is, best restaurant I've ever been to, and these guys suck. Okay? And the reason why is because there's a transaction cost involved in submitting your review, and so only people with strong feelings are going to do it. Same is true. Basically what we're doing here, in my opinion, is that we're turning course evaluations into Yelp, or rather, even more like Yelp. Okay? So what the university has decided to do, what the Department of Economics has decided to do, because we're economists, we're smarter than everybody else, so we figured out this problem, and because we talked to statisticians who are really smarter than absolutely everybody else, we have observed there are really seriously negative consequences of this, because the only piece of information the university has about the so-called quality of my teaching is the numbers that you put in. So if we don't get half of you put your numbers in, we have no idea what we're looking at. So what we decided to do is this, as a department, is that you can go on there and do it anytime you want, and next time we meet, there will be 15 minutes of the period devoted to you taking out your laptops or your smartphones or whatever other, your Google Glass or whatever it is, and logging in and doing this. And it will be very hard for anybody, I won't be in the room, and it will be very hard for anybody to know whether you're doing that or playing Glendoku. And for reasons that are perverse, in my opinion, and completely not understood by me, we're, for some reason, unwilling to force you to do it. There's lots of schools that just force you to do it. And for some reason, Berkeley, we're not willing to force you to do it. So what I ask is this, that on Thursday, you bring a device with which you can get online and do this, and please do it. It will make a difference. You should say whatever you think is true, but please say something. Because if we wind up with low response rates, it's very hard for anybody to claim that those numbers really represent anything meaningful about my teaching quality. But the academic senate doesn't care about that. They're just going to judge me on the basis of those numbers. And the same applies to every other instructor on campus. So please do bring your laptop. You know that you're all behavioral types. You know that if we don't make you do it in class, you're not going to do it. So just show up. Be good. Fine. Thank you. End of moralization. I will now step off my soapbox. Okay. Now, I hope we'll all be very pleased to hear that this computer is going back to the manufacturer. I've deemed it to be substandard and unacceptable. So I'm going to go and get my fourth laptop for 2014. In the meantime, we will struggle through 2 more lectures, and today we're going to talk a little bit more about this topic of heuristics and bias. What was happening here? I know, I'm supposed to switch to this device. Great. So we're going to talk a little bit more about this whole topic of heuristics and biases. I'm going to introduce a couple of new observations, a new fallacy, or sort of anomaly, the conjunction fallacy, and a new sort of set of biases. We talked about base rate neglect as a possible bias that people have, and we'll look at availability bias and representativeness bias as well, and sort of investigate how much progress we can make explaining these things using a model of base rate neglect, and when we might have to actually abandon that. Okay. I don't want the charm menu. I don't want an eraser. I want you to move the slide forward. Worked in my office. Not working now. Maybe if I do that. Okay, that didn't help. Come on. Quite literally every single time I use this device, I sit in my office for an hour, I get it exactly the way I want it, I go into the classroom, and it functions differently. I asked for a show of hands in my graduate class whether I should send it back to Dell or just throw it through the window. I think I might get more satisfaction from throwing it through the window. Okay, there are 2 groups, 2 handouts. Please don't look at your neighbor's handout. Following question. So this is for you to do on your own. So this is a classic, as you're used to this trick by now. This is a classic experiment. Hey, let me get your full attention, please. Shh, stop chatting. Here's how it goes. So consider the following description. This is from back in 1974. So if the political connotations that don't resonate fully, try to put yourself in the past. Linda is 31 years old, single, outspoken, an outspoken female, very bright. She majored in philosophy. Philosophy, right, is one of those sort of weird left-leaning humanities fields. As a student, she was deeply concerned with issues of discrimination and social justice and also participated in anti-nuclear demonstrations. Okay, so these are signals, yeah? Now what you have in front of you, and you have a different set of answers for the 2 groups, is 2 sort of hypotheses. Based on these signals, which of these hypotheses do you consider to be most likely? I'm going to start with group 1. I want you to come up with your answer promptly and enter it in the next 7 seconds. Okay? Only if you are group 1. What? It should say group 1. Yeah. Okay. So group 1 and 3, 2, 1, stop. Okay. Group 2, enter your answer quick as a flash. Come on. And we'll go for 3, 2, 1, and stop. Now, a question that for all of you to answer, no separate groups, which I hope you will see the way in which this question is parallel. Imagine drawing a number at random somewhere out between 1 and 10. Imagine drawing a number at random from between 1 and 10. Okay? Which of the following statements do you think is more likely to be true? The number is odd, as opposed to even. The number is odd and prime, or no answer. All right, so everybody, quick as a flash, shouldn't take long to come up with an answer to that one. 3, 2, 17, pi, stop. Okay, now, I'm going to come back. No, I think I'll do the answers now. Okay, so here was, I got to go ahead of slide. Okay, so here was the answers, group 1's answers to the Linda question. Okay, and the overwhelming majority said A. which is actually good and makes you smarter than the average bear. So this is annoying because you guys are not actually going to show the result that I want. So this is, wait a minute, no, I'm wrong. This is great. This is the way I want it. Okay, so group 1 was asked this. Is it more likely that Linda is active in the feminist movement or that Linda is a bank teller and is active in the feminist movement? Okay? And the overwhelming majority of you saw that it's much more likely that she's a feminist than that she's in the limited subset of feminists who are also bank tellers. All right? Whoops. Ooh, what? Sure, why not? All right. Oh, I love it. Beautiful. There's group 2. Now, here's the question that group 2 was asked. Which of the following statements is more likely to be true? Linda is a bank teller, Linda is a bank teller, and is active in the feminist movement. And I captured 46% of you with your pants down, believing that it is more likely that Linda is in the limited subset of bank tellers who are feminists than that they are in the broader supercategory of all bank tellers. Okay? Okay. Now, we're going to come back in a bit. We're going to talk about why this happens, and we're going to talk about why it happened for group 2 and not for group 1. But first, I just want to convince you that you are all at least more or less sane. It's not just that the people in group 2 somehow magically were like the bozos and went up and said, I don't know, I'm feeling kind of sleepy today, I'll take the group 2 handout. Everybody gets this right when it's obvious, right? Right? The numbers from 1 to 10 go like this. Okay? There's the odd numbers, there's the prime numbers, there is the intersection of the two. Anybody can see that the probability you're in the intersection of two sets must be less than the probability that you're in either of the sets. Right? So nobody, not nobody, but virtually everybody sees that, that this is, and that's what we saw for, and we're going to just allow the 10% that said B to be sleepy. And that's what we saw in the first one. So I'm going to hopefully explain to you my idea, what behavioral economists think is going on, as to why group 1's answers to what's called the Linda anomaly look more like what you said for prime numbers and odd numbers, where there's really, it's sort of mathematically obvious what's going on with those numbers. Okay. Any questions about this? Anybody in here want to sort of like explain themselves? No, come on, I've said too many things. Too much has been said. See that okay, go away. All right, so we've seen this already. I mean, I said this already. Basic set theory. I'm just always trying, I try over and over again to come back to something concrete, theoretically provable, or mathematically provable. So here we are, a little bit of set theory. Suppose that I have two sets. There's set B. Inside it I have set A, right? It is provable, and you won't need it to be proved because it'll be obvious that if A, so that little thingamajigger says is a subset of, so this says A is a subset of B in the sense that it is a set that is contained within B but isn't B. This, with a little line under it, is a more general thing that says A is a subset of B and could actually be B itself. But technically B is a subset of B, okay? So whatever. That's just some picky notational stuff. It doesn't matter. If A is a subset of B, then obviously this is, the probability of A being true is obviously less than or equal to the probability of B. Yeah? I don't need to prove that to you. That's obvious. Okay? Now, let's think about what a conjunction is. Let's go back to, this is set A, and it's going to be rainy days. This is set B. You all remember this. This is going to be the set of cold days. This is the intersection of the two. Okay? The intersection of A and B is a subset of B, right? Cold rainy days is a subset of cold days. This object here, this intersection, is what's referred to as a conjunction. I'm really sorry about the handwriting. This is the best I can do with the technology available to me. This is absolutely beastly. Because you know what will happen if I start using this? It'll suddenly start rocketing off into the next 15 slides of my... Yeah. Each of these things, A and B, are what are called constituents. I should just be doing this on the board. So A and B are constituents of the conjunction A intersection B. Okay? So obviously, it must be the case. These two things tell us that the probability that it is rainy and cold must be less than or equal to the probability that it's cold. Okay. Of course those little icons don't go away. Why would they go away? Okay, sure, I want to magnify things. Okay. The conjunction fallacy is simply when you estimate that the probability of a conjunction is greater than the probability of either one of its constituents. So if I were to say to you, which is more likely right now? So it happens to be a cold and rainy day right now. So which is more likely, that it's cold and rainy or that it's cold? Which is more likely, that it's cold and rainy or that it's rainy? This is not confusing to us. We know, right? The same as with the primes. So, but there are situations, and I've caught half of you in this, or half of you, in situations where for some reason you think of the constituent, right? Linda is a bank teller as being more likely, that you think of the conjunction, Linda is a bank teller and feminist, as being more likely than one of its constituents, that Linda is a bank teller. So we're going to talk about why that might be. Okay, so here's group 2. And you guys are the ones who were guilty of the conjunction fallacy in larger numbers. Okay? Is that right? Am I getting this right? Active is the constituent version. Yeah, okay. So bank teller is the constituent, right? And bank teller and active in the feminist movement is the conjunction. Now what's going on here is that the constituent, bank teller, is not particularly representative of the, so bank teller is a hypothesis. We don't know. The signal is, so I'm going to characterize, we have a set of signals here, and I'm going to characterize these as being the signal that Linda is liberal, or a liberal, okay? Bank teller is a hypothesis. Bank teller and feminist is another hypothesis. One is a subset of the other. The constituent bank teller is not, in some sense, representative of a liberal, okay? It doesn't, in our minds, it's not a representation of liberal. When you say, hey, look, so-and-so is a liberal, we don't immediately think, oh, bank teller, right? Bank teller doesn't paint a picture that represents a liberal to us. Active in the feminist movement does, right? For most of us, at least in this society. Active in the feminist movement is a hypothesis about who this person is, that in some sense paints a picture that represents in our minds the signal liberal, okay? And so what we do is we jump to the hypothesis that is most representative of the signal, okay? So that was group 2. Those were the folks who did commit the conjunction fallacy, yeah. Sorry? Went to C, no answer? I'm assuming that an answer of C in a question like this means it's lovely to see you, Professor Ackland. I'm not quite awake. I think that's what C means. I'm going to go with that. If anybody who said C on some sort of political grounds or something like that, Professor Ackland, I am unwilling to make a statement about liberal bank tellers. Let me know after class. Here's what's going on in group 1. Did you have a question, Alex?
Oh, I don't volunteer for my logic to be some kind of curious. I felt this right, but the way I interpreted it was something different from what you're describing. Because when I read A and B, I basically said, well, A is the inverse of B, right? So I made the entire circle, or let's call 100% of B bank teller.
So you thought A was non-feminist bank tellers?
Yes.
Interesting. All right, there's a paper in that. We'll write it together. I've never heard of that before. Okay. What I can say is that, as with everything else, almost everything else we've studied, we got heaps of other evidence of people doing stuff like this in different kinds of situations that sort of converge on the idea that what people are doing is pulling out something that seems representative. So that may be an additional influence that adds to that. Yeah. I'm sorry. Thank you. Excellent. I love that somebody, it should be me, but somebody does the reading. So I'm working on it. Don't mention this in your student evaluation. Professor Ackland was knowledgeable about something. What happened to group 1? This is the conjecture that we have. Okay. Here, the constituent, Linda is, right, so the conjunction is the intersection of feminist and bank teller. This constituent is not representative of liberal. This constituent is. So when we gave you, right, so this is the constituent, this is the conjunction. When the constituent is representative of the signal, right, when we think of active in the feminist movement, that paints a picture that looks like is representative of a liberal, or a person who has liberal beliefs, then you get it right. Then your mind isn't drawn to the more representative conjunction, okay? All right. Yeah, so conditional probabilities, right? So you get that all of this is just Bayes' rule, right? So this guy was doing so good all semester long. You don't know this, but on the second day of the semester, I had to ask the gentleman who teaches before our class to erase before the chalkboard, which was a useful lesson in the importance of norming, because he didn't actually understand that that's what normal people do. What we're doing is we're inferring the probability of a hypothesis given that we've observed a signal. The hypothesis is bank teller, and active in the feminist movement, and the signal is liberal. And so what we do is we inflate the probability of a hypothesis that is representative of the signal. Okay? Fine. Yeah, so if, another way of putting it is that we inflate this if H, in some sense, I might say, resembles I, or looks like a picture of I. Okay. Oops. So so this is an example. So I'm just going to sort of say a little bit about the term heuristics and biases. Okay, so this is an example, and I kind of touched on this last time. The representativeness heuristic says that you should evaluate conditional probabilities, or that people do, as a rule of thumb, as a shorthand, evaluate conditional probabilities by the degree to which the hypothesis is representative of the signal. And if you're in a hurry, right, and let's say you were trying to choose not between bank teller and feminist bank teller, but between bank teller and executive director of a nonprofit organization, without knowing anything else about Linda or the world, you could say, well, the majority of nonprofit, well, no, maybe not. I don't know if this is even true anymore, but let's say, let's say that it's not just a general, something like a, I don't know, gun control nonprofit advocacy group or something. Say, okay, well, the executive director of one of those is much more, that's a picture that represents liberals much more than bank teller represents liberals, and it's probably a pretty good rule of thumb. But here we're choosing between two categories that don't overlap, so we're not at risk of committing the conjunction fallacy. It's a pretty good rule of thumb. That's a heuristic. The bias, representativeness bias, happens when inferential errors caused by, representativeness bias is defined as inferential errors caused by the systematic failure of the representativeness heuristic. So the conjunction fallacy is an example of people using the representativeness heuristic in a way that systematically biases their probability inferences always in the same direction, right? So so you see sort of like when the constituent, bank teller, was non-representative, the representative, let me go back and say this more clearly. Where was I? Yeah. So when the constituent is representative, then the representativeness heuristic is a reasonable rule of thumb. Hey, that's a good picture. Adding in bank teller just muddies the picture, right? Active in the feminist movement is a much more crisp and clear picture of a liberal, clearer representation of a liberal than chucking in bank teller, which just muddies the waters. So the representativeness heuristic doesn't create a bias. It doesn't cause a mistake. It works pretty well. When the constituent, which should be the right answer, happens to not be representative, you're just using shorthand. You're just using a rule of thumb, a heuristic. It's good in lots of situations. This is a situation where it happens to cause a bit of a meltdown. Okay? So a bias is when a heuristic doesn't work, and in particular, it's when it doesn't work in a systematic way. It gives you the wrong answer in a systematic and predictable way. All right? So. All right, now let's see if let's dig into some math. I'm going to drag you through Bayes' rule again.